Probability distributions, expected value, example 2. Luke rolls a pair of dice in a game of chance that costs €2 to play. The table on the right gives the financial outcome of each event. We are to calculate the financial expectation for this game, and then we're asked, is it a fair game? We are firstly going to work out the probability of each of these outcomes happening. It might be useful if you're not familiar with rolling 2 dice to make out the sample space. There's 36 different outcomes when you roll 2 dice that it could add up to. I'm familiar with the sample space and I'm not going to draw it out here. So we're going to use logic to figure this out. If you roll 2 dice, the odds that the total would be a double, if you think about this, there are 6 types of doubles you could get out of 36 options. Double 1, double 2, double 3, etc. And 6 out of 36 is a 1 in 6 chance of rolling a double. The probability of rolling a total of 7, there are 6 out of 36 ways of doing this, or 1/6 of the options. It could be like a 1 in 6, 2 in 5, 3 in 4, or the opposite to each of those. The probability of getting an odd number that's not 7, well, of any odd number, half of the options will be odd. To get an odd number, you need an even with an odd. So half the ways you would roll dice, a pair of dice, would be odd. But the odd not 7, since 1/6 of these are 7, so the answer odd not 7 would be a half take away the 1/6. Now a half is 3/6. 3/6 minus 1/6 will be 2/6. You can call it 1/3 either, but we might leave it in 6 just to keep it the same denominator. And the last probability we're trying to work out is the probability that we get an even sum except the doubles. So the way you could get an even sum is if you roll 2 evens or 2 odds, the total would be even. So half the ways you would roll dice would end up in this, but 1/6 of these are doubles. So again, a half minus 1/6 is 2/6. So this is the probability of each of the options. Now let's consider how much we would win or lose for each of these options. So in total, so what's the amount that we would win? Well, if we rolled a double, it says we win €4, but we don't really win €4 because it costs €2 to play. So if we roll a double, we'd have, take the 2 from the 4, we'd be up €2. We win 3 with a 7, but again, it just means we're up €1. We break even if it's an odd sum, not 7. And we lose 3 on top of the €2 that we pay to play it if we get an even, not double. So that would be, we'd be down €5 then. So these are the amount we'd win or lose for each of these options. Now to work out the expected value, we're going to multiply these. So the formula is we multiply each of the probabilities by the amount we're going to win here. So I'm going to multiply the x value, the amount we'd win, by the probability of each. And again, this answer would be in euros. So multiplying these, we have 2 by 1/6 would be 2/6. I could put it into thirds, but I'm going to leave it in 6 here just because it'd be easier to add it up later. I have 1 by 1/6, so that's 1/6. 0 by 2/6 is 0. And -5 by 2/6 is -10/6. So adding up these, when we sum these, we see we have 2 and 1, which is 3/6, but take away 10/6 will be -7/6. So our expected win or value here would be on average -7/6. Now if I put that into the calculator, we'll see what that is in decimal form. So -7 divided by 6 is -1.1666. The 6 is circulating. So to the nearest cent, that would be -1.17, or €1.17. So we'd expect to lose €1.17 on average every time we play this game. Is this a fair game? Explain your answer. If a game is fair, what it means is you'll neither win nor lose on average. So the expected value here should be 0 in a fair game. So because this game has an expected value of -1.17, we could comment that this is not a fair game.